Good morning, children. Welcome to Maths B Circles Class 3 session. Today we are going to learn how to find the equation of the circle given 3 points on it and the procedure to find the equation of the circle when 3 conditions to find G, F, C are given and to check whether given points are consecutive or not. We also find the values of unknowns if the given points are consecutive. It's an application. Before going to start our session today, let us recapitulate what we have learned in our previous class. We have learned how to write the equation of the circle when endpoints of the diameter are given. And we have also learned the parametric equation of the circle. We have discussed the procedure to find the equation of the circle when 3 points are given. Children, what is the equation of the circle when endpoints of the diameter are x1, y1, x2, y2? That is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. If h comma k is the center and r is the radius of the circle, s is equal to 0, what are the parametric equations, children? X is equal to h plus r cos theta, comma y is equal to k plus r sin theta, where 0 less than or equal to theta less than 2 pi. Here theta is a parameter. And we have also discussed the procedure in the last class to find out the equation of the circle when 3 points on it are given. Now let us see how can we check. We also discussed the procedure to check whether the given points are consecutive or not. Now today, let us solve the problem. What is the aim? To find the equation of the circle. Under what condition? Under the condition when 3 points of the circle are provided. Let us do it through a problem. Find the equation of the circle passing through the points P1, 1, Q2, minus 1 and R3, 2. When we are going to find the equation of the circle. Before doing any problem, let us write the given data. Solution. Given points. Write the given points P1, 1, Q2, minus 1 and R3, 2. And we need to find the equation of the circle. Let us take the general equation of the circle as the required circle. Now, here our aim to find the equation of the circle. To get the equation of the circle, we need to find out 3 unknown values G, F, C. Let x is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0 with the required equation of the circle. We have this circle passing through the points P, Q, R. It means P lies on the circle. Using that condition, P lies on the circle x is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. What shall we get? We are going to substitute the point in the equation of the circle. When a point lies on the curve, it satisfies the equation of the curve. That is, wherever there is x in the equation, we will substitute x coordinate of the point. Wherever there is y in the equation, we will substitute y coordinate of the point. So x square will now become 1 square, y square will now become 1 square, 2gx will become 2g into 1 plus 2fy is 2f into 1 plus c equal to 0. Let us simplify. 1 square is 1, 1 square is 1, plus 2g into 1 is 2g, plus 2f into 1 is 2f, plus c equal to 0. In left hand side, let us keep only g, f, c terms and take the constant onto the right hand side, which will become 2g plus 2f plus c is equal to minus 2. This is equation 1. Observing the equation 1, what we will know is, substituting the point on the equation of the circle, we get an equation involving G, F, C. So corresponding to P, we got an equation in terms of G, F, C. So when we substitute Q also, we will get the same kind of equation. So 2, minus 1 is substituted in the equation of the circle and then simplified, and that number is taken onto the right hand side. And left hand side is the equation in terms of G and C. And corresponding to Q, we got equation 2. Now let us substitute R3 comma 2 lies on the circle. S is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. And what shall we do, children? We substitute the point R3 comma 2 in the same case, in the same way as we done in the previous cases. And x square will now become 3 square, y square now will become 2 square, plus 2gx will become 2 into 3 into x plus 2 into 2 into f plus c equal to 0. Let us simplify 3 square plus 2 square. 9 plus 4 and take 9 plus 4, 13 onto the right hand side will become minus 13. Left hand side will be 6g plus 4f plus c. Now we have equations 1, 2, 3 involving g, f, c. To get the value of g, f, c, I will take two equations at a time. Taking 2 equations at a time, subtracting equation 1 minus equation 2. Children, I am taking equation 1 minus equation 2 because observe the equation 1 and equation 2. Here, the coefficient of c is always positive for whatever the value of the points you substitute, whether it is positive or negative. Because c is free from x comma y, the sign of c is not going to be affected by the substitution of the point b x comma y for different values. Therefore, if you subtract, c will get cancelled and we will get another equation 4 in terms of g and f. We have done with equation 1 and 2. Equation 1 minus equation 2 gives us equation 4 in terms of g and f. Similarly, let us take equation 1 minus equation 3. You can also do equation 2 minus equation 1, equation 2 minus equation 3. It doesn't matter. Okay. Equation 1 minus equation 3. Write the first equation under which you write the equation 3. Forget not to change the sign of the second equation when you subtract. CC get cancelled, you'll get an equation in terms of G and F. Let it be equation 5. If you observe, equation 4 and equation 5 are exclusively equations in G and F. Solve the equations 4 and 5 in any of the methods you are comfortable and obtain the values of G, F. Substitute this G comma F values in one of the equations involving C. Can be equation 1, can be equation 2 and can be equation 3. Then we'll get C is equal to 4. Now this G, F, C values give us the unique equation of the circle. When substituted in the equation S is equal to 0, which is S is equal to x square plus y square minus 5x minus y plus 4 equal to 0. So have you followed this procedure? Just substitute the point one after the other and solve the simultaneous equations for the values of G and C. This is method 1 of finding the equation of the circle when 3 points on it are given. Now we'll also discuss method 2. Before going to method 2, let us solve another important problem which may come in IB also. Many times it has come for 7 marks fashion. We have a question here. If 2, 0, 0, 1, 4, 5 and 0, c are consecutive, find the value of c. What are consecutive points, children? 4 or more points are said to be consecutive if they lie on a same circle. Same like collinear points in the concept of straight lines, in the chapter of straight lines. What are collinear points? 3 or more points are said to be collinear if they lie on a same straight line. Here, 4 or more points are said to be consecutive if they lie on a same circle. That's all. That means given points are consecutive, which implies all the 4 points lie on the same circle. So these 4 related are the points related to the same circle. This is a condition provided to us. Using that hint, we have to find the value of c. Is the question clear, children? First, what should we do? Solution. First, we have to write the given points and name the points. A first point, B second point, C third point, and D fourth point. Given points are consecutive, so all the 4 points A, B, C, D lie on the same circle. Same the method that we discussed in the previous question. Substitute. Let us take the general equation of the circle. Here x square plus y square plus 2gx plus 2fy plus k equal to 0 with the required circle I have chosen. Because in the question already we have C in point D. The coordinates are 0, c. Again, I named a point as C. So not to get confused with so many C's, I have taken the constant in the equation of the circle as K. Now the first point lies in the circle. Substitute and simplify. Then what shall we get? 4g plus k is equal to -4. And 0, comma 1 is also a point on the circle which gives us 2f plus k equal to minus 1. Children, if you observe, substituting when a 2, comma 0 in the equation of the circle, we got an equation in terms of g and k. There is no f term in the equation 1 because y coordinate of the point a 2, comma 0 is 0. Therefore, that y coefficient to f will be 0. In the similar way, when b 0, comma 1 is substituted in the equation 2, have you observed there is no g term in the equation 2? Yes. When we have a point C 4, comma 5 lies on circle S is equal to 0, we will get both G and F terms along with A because both X coordinate and Y coordinate are present. So this is a technique that we need to observe how equations are changing by substituting the different kinds of points on the circle. Now let us solve the equations 1, 2, 3. Then for what? For gaining the values of G, F and K. Substitute this G, F, K values in the supposed equation of the circle. We'll get the required circle S is equal to x square plus y square plus 2 into minus 13 by 6 into x plus 2 into minus 17 by 6 into y plus 14 by 3 equal to 0. That is, on simplification, 3 times x square plus y square minus 13x minus 17y plus 14 equal to 0 is the required equation of the circle. This is the required equation of the circle using 3 points. But our aim is not to find the equation of the circle alone. We need to find out the unknown value of C. Remember? So this is the extra step that we need to do when comparing to the previous problem. We also had a point D0, comma C lies on S is equal to 0. Why D lies on S is equal to 0? In the question it is not mentioned that D lies on S equal to 0. Do you get that doubt? We should not get, because in the question it is mentioned that points are concyclic. When points are concyclic, all the 4 points lie on the circle. So it is the result that we get from the word concyclic. Points are concyclic. So substituting D0, comma C in the equation S is equal to 0. We'll get 3c square minus 17c plus 14 equal to 0. It's a second degree equation in C. How to get the value of C? It's a quadratic equation. When we solve the equation for roots, we'll get C is equal to 14 by 3 or 1. So we can choose one of the value for C here. By one of the value, let us take if C is equal to 1, what happens? If C is equal to 1, we have a point S 0, comma C. And is equal to 0, comma C is now 1 in this case 1, 0, comma 1. But this 0, comma 1 is the point already given in the question as Q. So we need another point. We should see when the points are concyclic, 4 or more points are said to be concyclic. So at minimum 4 points must be there in order to have the concyclic points. Therefore, C cannot be 1. If C is equal to 1, it's becoming the old point which is given in the question. So it should be any other, it should be other point than given 3 points. Therefore, C is equal to 14 by 3. For this explanation, you will be having a mark in your final exam. Now, how to find the equation of the circle when 3 points are given in method 2? Let us see another method to find the equation of the circle passing through 3 given points. We have the same question and let us check whether we get the same answer or not. Find the equation of the circle passing through the points 1, comma 1, 2, comma minus 1 and 3, comma 2. Step 1. Let the given points be A1, comma 1, B2, comma minus 1 and C3, comma 2. We are naming the points. And SH, comma B, K be the center of the required circle. Here first we shall get center. What is the center we are taking? SH, comma K. When S is a center, A is a point on the circle, SA will become radius. As B is also a point on the circle, SB will also be the radius. Similarly, SC will also be the radius. So SA, SB, SC. All these 3 distances are equal distances which are equal to radius of the circle. Therefore, SA is equal to SB is equal to SC. From which we'll get SA is equal to SB and SA is equal to SC. So from that condition, we are generating 2 sub-conditions with which we'll get two equations. So our aim is to get the equations so as to solve. In the previous question, we have three equations. Here we are generating only two equations. Why? Because here the unknowns are h comma k only. Two unknowns. So correct number of the unknowns should be equal to the number of the equations or number of the conditions. So to solve h comma k, I need two equations involving h and k. That's why we are trying to frame the two conditions from which we'll get the equations. What are those conditions? SA is equal to SB and SA is equal to SA. Let us take condition 1. SA is equal to SB in step 3. Since SA is a distance and SB is a distance, here I have also written what is S, what is A and what is B. SA is the distance, SB is the distance. Distance formula is, we know, root under root x2 minus x1 whole square plus y2 minus y1 whole square. So in order to simplify easily, we will square on both sides, with which we'll get h square is equal to sb square, and we know the distance formula. S is h comma k and a is 1 comma 1. H minus 1 whole square plus k minus 1 whole square. It's equal to SB. S we have h comma k and b we have 2 comma minus 1. SB is h minus 2 whole square, k minus of minus 1 whole square, which is k plus 1 whole square. Just expand both right hand side and left hand side using a minus b whole square and a plus b whole square formulas. H square terms and k square terms gets cancelled on either sides and we'll be left with 4h plus 2k actually it is. 4h plus 2k plus 2k minus 11 equal to 0. Now step 4 is SA is equal to SC. Again, in order to remove the square root, we'll square on both sides. We'll simplify. Squaring on both sides. SA square is equal to SC square. We have SH comma k and A1 comma 1. So we can find SA square using the same formula. Root x2 minus x1 whole square plus y2 minus y1 whole square. And S is S is h comma k and C is 3 comma 2. Again, we'll simplify the above equation using A1 is b whole square. And h square terms and k square terms gets cancelled. We have 4h plus 2k minus 7 equal to 0. In step 3, we have equation 1. In step 4, we have equation 2 involving h comma k. Solving these two equations, you can solve the equations in any of the methods you are comfortable that you have learned in your previous classes. We'll get h comma k values. Now we have h comma k in the sense we have the center of the circle. Then how can we find the radius of the circle? The distances SA and SB, SC are equal and all equal to the radius of the circle. You know S and you know A. Find out SA, which is where S is equal to the point that we are going to get h comma k, and h comma k is 5 by 2 comma 1 by 2, and A is the point 1 comma 1 given in the question. Now using the distance formula again, SA equal to SB equal to SC, you can find any of the distances, which is root 5 by 2. So with this, we got both center and radius. Using center and radius formula, standard equation of the circle, x minus h whole square plus y minus k whole square is equal to r square. R is root 5 by 2. When it is squared, it is 5 by 2. Is a required equation of the circle. It can also be expanded and can be put in the general form of the circle as x square plus y square minus 5x minus 5 plus 4 equal to 0 is a required equation of the circle. Children, with this we have finished how to find the equation of the circle and 3 points on it are given. Let us take another question where the 3 conditions are given, but not all 3 conditions are in terms of points. 2 conditions are in terms of points and another is a line given. Let us read the question. Find the equation of the circle which passes through 2, minus 3 and minus 5, 4, 5 and having the center on 4x plus 3y plus 1 equal to 0. So we have an equation, we have a circle. We have a circle in which we have a point A, B and the center of the circle minus D minus F is on a line L is equal to 0. Now we are going to find out how to find the equation of that circle. First, given points should be written. Solution. Let the given points be A2, minus 3 and B minus 4, 5. And the line L is equal to 3x plus, and the line L is equal to 4x plus 3y plus 1 equal to 0. And let us suppose x square plus y square plus 2gx plus 2fy plus c equal to 0 as the required equation of the circle. Step 1. A lies on the circle. So substitute the point A in the equation of the circle, children. And simplify. With which we will get 4g minus 6f plus c equal to minus 13 as we discussed in our previous problems. Step 2 is substituting the point B. B minus 4, 5 lies on s is equal to 0. So it is minus 8g plus 10f plus c equal to minus 41. I can also write it directly. If I have a point A2, minus 3, how can I write this equation directly? Multiply this x coordinate with the 2 children. 2 into 2, 4g, minus 3 into 6, minus 6f, plus some constant is always plus c, is equal to, this is x coefficient, x coordinate square, plus y coordinate square, 3 square 9, 2 square 4. 9 plus 4, 13, 13 taken on to the other side. See here, b minus 4, 5. Shortcut to write the equation is minus 4 into 2, minus 8g, plus 5 into 2, 10f, plus c is equal to square x coordinate square plus y coordinate square. 4 square 16, 5 square 25. 25 plus 16 is 41. Transposing other side with respect to addition, it will become minus 41. So this is a short way to write. Now we have equation 1 and 2 involving G, F, C. Let us see the third condition. Step 3. Given that center of the circle minus G minus F lies on the line, L is equal to 4x plus 3y plus 1 equal to 0. See, the point lies on the circle. We substitute the coordinates of the point in the equation of the circle. Since this point is on the line, we substitute the coordinates of the point in the equation of the line. So in case of x, we'll substitute minus g. In case of y, we'll substitute minus f. So minus 4g minus 3f plus 1 is equal to 0 is the equation P. Now we'll have equation 1 minus equation 2. Why only equation 1 minus equation 2? In order to eliminate C. So 3g minus 4f equal to 7 is the equation 4. And now we'll solve equation 3 and 4 so as to get the values of g and f. Here g is equal to 1 and f is equal to minus 1. Substituting this g and f values in any of the equations gives us c. Not only equations 3 and 4 can give us c, children. So we have to substitute. Substituting these values in the supposed equation of the circle, we'll get x square plus y square. G is 1. So 2gx, 2 into 1 into x 2x plus 2fy, 2 into minus 1 into y. So minus 2y plus c. C is minus 23 equal to 0 is a required equation of the circle. With this, we have finished today's session, children. You have the similar kind of questions in the exercise. Please solve the exercise problems of the same method in the exercise 1A. And we have completed all the important concepts of our first exercise. So solve the problems given in the exercise 1. Go through the examples to have the command of these topics. And I didn't discuss the proof of getting parametric equations in the circle. So I request the children to go through the textbook and read the text. We have already discussed the procedure. try to get some theoretical knowledge how it was possible to get x is equal to h plus r cos theta and y is equal to k plus r sin theta as parametric equation for the circle for 0 less than or equal to theta less than 2 pi. Thank you, children.